Hello, I'm Roger Scheffler, Food Safety Specialist at CFS. Today, I would like to go with you through the introduction to infrastructure hygienic design. This session covers three aspects: the hygiene design principles of infrastructure for food facilities, the application of hygiene design principles in decision-making processes, and how to maintain the conditions of the infrastructure. First of all, the reason of emphasizing the hygienic design of infrastructure is that the infrastructure design can create controllable environments and effective defense for food factories. It includes actually three lines of defense. The first line is to control the transfer of hazards from the outside to the inside of the plant. The second line is to control the transfer of hazards from one area of the plant to another, such as the cross-contamination between the raw area and the ready-to-eat area. The third line is to control the transfer of hazards in the same production area, such as cross-contamination from a non-food contact surface to a food contact surface. Therefore, in order to ensure the integrity of the plant, the food factory needs to establish a hygienic zoning based on the risk to create a controllable environment. So, how does the factory execute the hygienic design for the infrastructure? First of all, in order to give consideration to both food safety and plant operation efficiency, we will follow the effective and minimum design concept and determine the design level based on the risk and product type. Then we will establish a cross-functional team and introduce experts from all aspects. The team can use the HACCP risk assessment method and refer to the principles of infrastructure sanitation design for infrastructure sanitation design assessment. This slide shows who should be in cross-functional team and also listing more resources and guidance information. Now, I would like to take the principles of infrastructure hygienic design provided by GMA as an example to introduce how to use these principles. GMA's hygienic design principles for infrastructure include 10 main principles, including hygienic zoning, water drainage in the plant, travel pattern and airflow control, workshop environment requirements, building structure and construction requirements, internal facility design and construction requirements, utility design requirements, and design requirements for the sanitation system. Each principle can be divided into several specific requirements. Here we take the first principle as an example of hygienic zoning. The list contains 6 specific requirements. When using the principle, the factory can review it one by one according to this list. The infrastructure hygienic design principles recommended by GMA are suitable for the producers of low water activity products, like bakery goods, for instance. In addition, AMI, American Meat Institute, has also the hygienic design principles recommended for meat and poultry producers. Both principles from GMA and from AMI are available on our CFS website. So, when the factory has to make a material choice within a project, there are multiple aspects to consider. Here is a list of hygienic choice considerations that may guide you through the selection process. Material durability, material cost, installation methods, installation costs, time required for installation, impact to production schedules, material cleanability, cleaning methods, future cleaning costs, and future maintenance costs. When talking about infrastructure, the factory will also discuss about the material selection and the design of walls, ceilings and floors. Let's look at the advantages and disadvantages of various materials one by one. The surface of unsealed concrete wall is rough. It easily absorbs water and accumulates dirt, thus becoming a potential point of microorganisms and insect harborage, so it is generally not used in hygiene areas but more for wallways. If a coating is added to the concrete surface, the surface will become smooth and easy to clean, so can be then used in hygiene areas. From the functional point of view, the concrete wall with coating is not an insulating material, so it can be only used in the occasions with no requirements on the insulation. Same for the unsealed concrete. The Extrutech panels are light and easy to install. The material cost is relatively low. However, this kind of structure has low strength, potential forklift damage and cannot be penetrated. Hence, it can be used in production areas of food factories where an effective hall separation and clean wall surface is required. Fiber reinforced plastic boards are another way of creating a cleanable environment. As they have no insulation properties, the ground wall, concrete for instance, would have to bring the insulation. Wall tiles are easy to clean and can be replaced piece by piece when damaged. However, tiles does not have a good insulation property and it requires grouting during installation, which needs a long installation time. The grout needs regular maintenance with high maintenance costs. The surface of the metal insulated panels is smooth, easy to clean and has good insulation. However, due to the sandwich structure, it is easily damaged by hitting and therefore not be penetrated. The joints of the plates need to be sealed during installation. In general, all kinds of materials have their advantages and disadvantages, so we need to always make a choice based on the specific application scenarios. Here are some more aspects that I would like to highlight in relation to wall, curb and ceiling design. Wall and curb surfaces drain freely without pockets, ledges and nooks. Interstitial space should allow access to clean and inspect overhead elements and prevent wall and ceiling panel penetration in order to not create harborage sites for soil and pest. When selecting the floor material, the factors like corrosion resistance, wear resistance, heat resistance, installation time and cost of the material shall be considered. The most appropriate material shall be selected according to the application scenario. In addition, the factory can also consult with flooring manufacturers and service providers to recommend appropriate materials and solutions. This table shows guiding information for a good floor material selection, and please feel free to consult it when making your floor material selection. The floor should be easy to clean, non-permeable and wear resistant. During the installation of the floor, it is necessary to pay attention to the control of the moisture content of the cement base. If the moisture content is too high, the deformation of the foundation will occur and the integrity of the upper coating will be affected. In addition, the floor should maintain a certain slope, generally at least 1 degree. That means there is a height difference of 1 centimeter per 1 meter or 0.4 inches per 3 feet, which is conducive to self-drainage. Let's look at the floor drain design. When talking about the drainage system, in addition to maintaining a certain slope, there should be enough drains which are complying with sanitary design requirements. You can see here on the slide two kinds of floor drains. On the left, one is a spot drain and the other one is a trench drain. Based on the planned requirements, you may choose either one. The hygienic design requirements for drains include the use of corrosion-resistant materials, and the surface should be smooth and easy to clean. Baskets with filters are provided to prevent materials from blocking the sewer system. A good drain is designed with a water seal and a P-trap. To achieve good drainage, a sufficient number of floor drains must be provided, and the floor should be sloped towards the direction of the floor drain with a slope of no less than 1 degree. The bases of the drains are supported to prevent settlement. In addition, drain lines should not tie into or pass through food production areas, and it is recommended to have different drainage systems for the different hygienic zones. Through the examples we just went through, I hope you may have a better understanding on how to use the principles of hygienic design to make choices and decisions according to different applications. The investment of infrastructure for food factories needs a lot of capital. The maintenance of infrastructure will determine the return rate of these investments. The food safety risk can also be reduced with good maintenance. The factory should establish a cross-functional management team with the participation of the heads of all departments. Then, the team could seek opportunities through daily internal inspections and audits, set up a special budget for infrastructure maintenance, and optimize preventive maintenance programs and the master sanitation schedule to improve the operation efficiency of the factory. So let's summarize. Infrastructure hygienic design requires subject matter experts. Choose hygienic design principles that fits your product type. Make decisions based on your application and design principles. And routine maintenance of infrastructure is critical to eliminate harborage and promotes more economical long-term costs. Thank you for watching. For more information, please feel free to contact us by email or visit our website at www.commercialfoodsanitation.com. Thank you.